afternoon, ladies and gentlemen. Welcome back here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries. I welcome you to have a seat, to have a free drink. It's all in the house. Lay back and enjoy the next topic regarding the ene.field project. And for that, we'll have a speaker. The representative for the ene.field project will be presenting the results from fuel cell micro-CHP demonstration. And for that, please welcome with me on stage Dr. Eva Ravn Nielsen. Big hands, please.
Thanks a lot for your kind introduction. My name is Eva Ravn Nielsen, and I have been preparing this presentation along with my colleague Carsten Prag. And I will take the opportunity, first of all, to let you know where we are from. We come from the Technical University of Denmark, DTU Energy, where we have a test center for fuel cell and hydrogen technologies. We offer testing of fuel cell and electrolysis, training of technical staff engineers, consultancy whenever there's a problem or troubleshooting at the companies, and we do a lot of project work. And one of the most exciting projects we deal with at the moment is the ene.field project, which I will tell you about in this presentation. When you want to know more about FCH Test Center and DTU Energy, you're welcome to visit our booth D62, and we also have a dedicated presentation here at the Technical Forum on Thursday, which I hope that you will have the chance to attend. But what I'm here to tell you about is the ene.field project. This project is the largest demonstration of micro-CHP units over Europe for private homes. And it will demonstrate up to 1,000 units of heat and electricity supplying systems over 11 countries. And the project started in 2012 and lasts for 5 years, so it will end late next year. Each unit will be demonstrated running for 1 to 3 years. And what we will contribute with, besides the experience and exchange of knowledge, development of the technology, is a number of analyses on the performance, documentation of how this technology works, and the potentials and the barriers for uptake of this new technology. First of all, I would let you know about what is micro-CHP. And it is a fuel cell-based unit that will supply your home with both heat and power. It runs on natural gas, and the size is around 1 kilowatt electric power. It will reduce the cost and the primary energy consumption of the home, and at the same time maintaining the comfort of your home. And it will enable private homes, private families to produce their own electricity and be more independent. It runs without pollution, only producing steam and CO2, and is rather silent technology. The consortium of the ene.field project gathers the leading European fuel cell micro-CHP manufacturers, as well as utility companies, research institutes, and a few organizations which are managing the project and making dissemination of results. I find it rather special for this project that we have 8 or 9 competitors, manufacturers. The companies, they go into the same field, they approach the same markets, but they have realized that they have to do this together and assisted by the research institutes, so that in order to create a market and to remove the barriers for the mass uptake, we all have to work together So we do this very efficiently, rather open as it can be, and exchanging experience and how it works. The project is supported from FCH joint undertaking by 26 million euro out of a total budget of 53 million. Each company has their own fuel cell micro-CHP unit that they are going to demonstrate, or they are demonstrating at the moment. And the project counts both SOFC-based and PEM-based units. And by now, if I can go to the next slide. Oh, that was a lot. Yeah. Sorry. Okay, at the moment, we have 445 units deployed, so installed in the field already, after a slow startup with a lot of challenges on how to finance the demonstration. We have found solutions and a rapid increase in the number of units installed at the moment. And we have, at the moment, 70% of the units based on SOFC, and 30% of the units right now in the field are based on PEM fuel cells. I'll just see how we're going here. Yeah. Contribution from the project will be a lot of documentation of how these units and this technology works, and exchange the experience and disseminate to the public the most favorable house types and regions for introducing the new technology. The training needs for technical personnel, which we find is not very coordinated, but each manufacturer has at the moment established their own courses for installers, which works very efficiently. An overview of regulation code and standards and the challenges that we are facing in this field. An overview of business barriers from us, uptake of the technology, documentation of the technical performance, smart grid integration capabilities, the environmental impact of the new technology, and finally, new business models. Here we have the slide I was looking for just before. We have now installations in 8 European countries. And as you may see from the slide, Germany represents more than half of the units installed so far. The project is issuing a number of reports. So when we are making an analysis, we are disseminating the results. And these reports are at the moment available. There's a review of the field support arrangement, there's education needs, an analysis of the European supply chain, regulation codes and standards, what are the grid connection issues and smart grid capabilities of the fuel cell-based micro-CHP. And since today, also non-economic barriers to market uptake report is available on the ene.field website. It's a preliminary version which will be updated later this year. I will go through a number of results, and it will maybe be a bit quick, but I will give you a taste of the kind of analysis that are available at the moment. We have been able to make a profile of the typical end user involved in the field trials. We have made a survey, so they are answering questionnaires, and after 1 year, after their installation, we go back with a new questionnaire asking how satisfied will you be. But the results at the moment is the characterization of the typical end user. They are, in general, environmentally concerned, and they actively work towards saving energy in their home. They are quite concerned about the future costs and supply of energy, security of energy supply. They do have positive expectation for their new fuel cell-based micro-CHP and are certain that it will provide them with the heat and power needs of their home. Most of them live in detached houses, which had a new natural gas boiler, which will be replaced by fuel cell micro-CHP. They have no kids living at home anymore, most of them, and they work full-time. So these are the front runners to take up this new technology, but this is the profile of the families involved in the present field trial. Then we also have an overview now of main non-economic barriers for the mass uptake. We need a predictable political framework that will reward more efficient energy systems and that we can rely on for the years to come. What will be the situation of this technology? It's important for people to invest in new technology. In quite some countries, we experience quite bureaucratic procedures for getting permission to connect the micro-CHP with the electricity grid and gas grid. And this is actually a barrier for making a mass rollout of this technology. We have to find ways to overcome this. And regarding the regulation codes and standards, all member states, they use international standards. But they supplement this with national variations and added requirements, which make it very difficult when you want to commercialize your product across countries. Because for every new country you want to enter in that market, you have to go, the manufacturer has to go into details. What are the specific requirements in this new place? This should be better coordinated. And finally, we have realized that the energy labeling of these units should find a better way of defining this energy labeling, because the present method of calculating is a bit misleading and does not acknowledge when a fuel cell micro-CHP has a superior behavior to other units. Now to the smart grid capabilities of these units. We have interviewed the manufacturers and utility companies asking, can your units and the present units available act in a smart grid? And the conclusions are pretty clear. Yes, the present technology is ready, is able to enter in a smart grid, helping out the electricity grid, stabilizing, making it more robust, can be remote controlled and go up and down, adjusted fairly quickly. But still, to act in this smart grid market, the costs of the micro-CHP is a barrier, and a better framework rewarding these services to grid would help this introduction and also relieve the fairly high upfront costs of the units. Approaching the end of my presentation, I will tell you a few headlines, further findings and conclusions that we have. We have successfully installed around 450 micro-CHP units in a number of various house types over 8 European countries. Germany has turned out to be the strongest early market, And this is due to the costs of electricity and gas, which benefit this new technology, is very much due to local funding, where there are support introducing this technology. And all this also makes the manufacturers and installer base in Germany stronger than most of Europe. We are continuously monitoring the units and collecting performance data. There will be analysis and the conclusions will be available to the public. Most of the reports will come out over the next year. Some reports are new and some reports will be updated and final reports of what has been issued already. I told you that the units are ready to enter a smart grid. The system capital costs are the major challenge for a market growth, and the requirement to drive the costs down will be a larger volume of production. This will both make it able to reduce the cost by economy of scale, and also more efficient outsource some products and components. And in order to realize this increased volume, we need, for some time, continued funding programs and a framework that will support making this technology able to reach mass market. The immediate next steps will be continuation of the deployment until we reach around the 1,000 units. The documentation of the technical performance by monitoring the units. We will deliver further analysis of customer satisfaction. And there will be market growth projection, detailed modeling of how this technology impacts European electricity systems. And finally, there will be a thorough analysis of the environmental impact, a life cycle assessment, as well as a life cycle cost analysis of the technology. And all these reports will be available to the public. It should be mentioned that the ene.field project could not be without funding from the EU FP7 fuel cell and hydrogen joint undertaking, which is making a fine financial support besides what industry and other organizations are already paying. If you want more information, you can go to the ene.field website, where also all the mentioned reports are available that can be downloaded. And you are welcome to contact us at the info at ene.field or send me an email. And here at the fair, you can meet us. Most of the manufacturers are present at the IBZ Initiative Brændstofcelle at E51, so you should go there and look at the actual units. And a number of other participants in the project are present here at the group exhibit, and as well as we are, DTU. And finally, I want to thank you all for your attention. Thank you.
Thank you very much for giving us an insight on the ene.field project. Are there any questions at this time? Okay, no questions so far here, but I'm pretty sure they will be taken to the booth. I'm curious, will you be an end user of the micro-CHP?
In Denmark, we have kind of the challenge that we have a lot of CHP large scale available already. So the extra benefit of making most of the primary energy is less of an issue in Denmark than in the rest of Europe. So not this year.
Not this year. Once again, thank you very much. That was Dr. Eva Ravn Nielsen.
Thank you.
We'll have a short break here. We'll be back in 20 minutes' time. And at 3:40, we will hear a presentation on the system automation of PEM fuel cells with prognostics and health management for improved reliability and economy. And for that, our speaker will be Mr. Federico Zenit, representing Zafir. Thank you very much. That will be in 20 minutes' time.